Okay. Uh, good evening, all of y'all. I am Dr. Gausia Banu, Associate Professor of Database Management System. Today I'm going to start Unit 1 of Narasimha Reddy College, UGC Autonomous Institute. So coming to this slide, what is database management system? First, before going to the what is database management system, let's see what is data. Data is collection of facts. For example, I got 60 marks in mathematics is a fact, is a reality. My salary is 90,000 is a reality. So this is nothing but facts. So reality is nothing but fact. So data is a collection of facts. So what is this database? A database is a collection of related data which represents some aspects of the real world. It is a representation of the real world. So real world is nothing but, you can tell, entity, real world entity. So we have coming with a new word called entity. Entity is nothing but entering into the real world facts. How can we do it? How can we manage it? What all precautions and what all the implementations and what all the conclusions and what all the techniques we have to follow, that we'll be learning in database management system. The second point is the database system is designed to be built and populated with data for a certain risk. Okay. Coming to the next slide. Database management system is a software for storing and retrieving users' data while considering appropriate security measures. Means DBMS is a software. What is a software? It's a set of instructions. So basically, DDBMS is a package. Package is nothing but software. So in the market, the difference between software and the package, we can learn in the future, coming to the future sections. So DBMS is a software for storing. We can store and also we can retrieve, we can get the data from the users while considering appropriate security measures. We have to know we have to keep even the security measures like user, password, etc., etc. So it consists of group of programs. So software is nothing but set of instructions. Set of instructions nothing but programs. So programs is again grouping of programs which can manipulate the database. So database management system accepts the request from data. It takes the request from data from the application and instructs the operating system to provide a specific data. So here what happening is at two ends. One is the user, one is the server, and the middle we have to see the operating system. Okay, so this operating system is nothing but the middleware. We can tell the middleware. So the last the server is nothing but where the database is being stored. And we can also store there from the server and also retrieve from the server and also give security to the server, etc., etc. So where it can be stored, how it can be stored, again that goes to the topic called database, data warehouse, data mining, or cloud computing, or fog computing. So this all so what the different types of storages goes on. So this is the other extension of this database managed system is nothing but structured and unstructured database management system. So coming to the unstructured like Hadoop, blockchains. So this is another different concept. So let's not go into the deep. Let's know the basic fundas. So coming to the next slide. Next. DBMS allows users to create their own databases as per the requirement, as per the need. So the users create their own databases with the help of the database administrator or the database writer. The term database manager includes the user of the database and other application programs. It provides the interface between the data and the software. So DBMS is a software. So this software is nothing but is interface between the user data and the software application data. So that is what. Next, some of the examples where we use the databases are university databases, train databases, flight databases, Aadhaar card databases, passport databases, hospital databases, books databases, banking, sales, HR, manufacturing, and telecommunications, construction databases, some road and transport databases. So many, for everything we will be storing a databases. So real world entities is nothing but data where we can store all the data. So it should have one platform that is called a base where all the data is stored in a platform that is called a database. So where we are able to manage the data in a platform in a data warehouse. So managing the data, so this all makes one type of programming. So that is called a database management system. We all are doing in this database management system in our own systems, or we are going for the online applications also. A popular database softwares which we can there and available in the market is MySQL, Microsoft Access, Oracle, PostgreSQL, DBase, FoxPro, Sybase, SQLite, IBM DB2, LibreOffice Base, MariaDB, Microsoft SQL Server, etc. Even Oracle, Sybase. Next comes DB Plus. Next comes informatics. So introduced by IBM, etc. Coming to the topic of our syllabus, the first topic is the historical perspectives. The important, the landmark for the history is we started at the year 1960 by Charles Bachman designed the first DBMS system. So when this DBMS evolution has started at 1960 by the person Charles Bachman. He designed it, but did not introduce to the reality world. But in 1970, EF Cord introduced um, information management system that is called IMS, who was working in IBM. So it was the invention with the basic funda of designing by Charles Bachman for the DBMS system. So 1970, EF Cord introduced the information management system. So later coming years, 1976, Peter Chen coined and defined the entity relationship model, also known as ER model. So in 1976, the upgrade was going on for the information management system, and the upgradation version is called the ER model. In 1980, relational model becomes a widely accepted database component. So what happening is using the ER model. ER model is nothing like a blueprint to the database, like a flow chart, how we are using in the programming languages. So it is nothing a model. Before constructing the building, we will have one type of prototype. Prototype is nothing but the, but in DBMS, what we can tell, it is called a ER model. So 1980, relational model becomes widely accepted database component. In 1985, Object-oriented DBMS develops. So now the object-oriented OOPS system was developed in 1985. OOPS system means object-oriented software, which was clubbed with DBMS concept. DBMS concept, again, the funda is information management system with the combination of ER model. In 1919, incorporation of object orientation and relational database management system was introduced. In 1995, the first internet database application started. 1997, XML means extended markup language applied to database processing. Many vendors or buyers began to integrate the extended markup language into database management products. So this is the history. So let's go through once again. 1960, who has done it? Charles Bachman. In 1970, EF called introduced information management system. In 1976, Peter Chen defined what is ER model. The 1980 relational model has been accepted with this collaboration of database component. 1985 OOPS system has been clubbed with DBMS. Next 1990 group orientation with relational DBMS has been clubbing. The first internet database application in 1995. So all this application was done in their own systems. But internet concept, the real revolution has started from 1995 with the help of internet. So we started sharing our knowledge from one end of the world to the other end of the world with the help of internet access. In 1997, apart from this internet, upgradation was going on for the database management system with the help of extended markup language. And many vendors was getting attracted to buy this DBMS product to highlight the businesses and make more profits and avoiding the concept of loss system and having the gain system. So loss and profit from the starting end to the ending end, where all the supply chain management goes on with the help of the DBMS products. Next, what are the characteristics of database management system? We have seen where it is used, how it is used. Now let's see the characteristics. What are the features of the database management system? What can it do? It can provide security and removes redundancy. Redundancy is nothing but duplicacy. The second point is self-describing nature of the database system. It describes itself. Database, its system itself is has a own definition. That means data, where all this data is stored in a base with the help of a system. We follow one system, like some rows, columns, some headers, some tupling records, some column nights called attributes, which I'll be coming in the coming sections. Next, the third point is insulation between programs and data abstraction. Insulation, that means isolation from the programs and data abstraction, from where the programs has been running and what is the abstraction of the data. Next, supports a multiple views of the data by using the view command in the database management system. Apart from, we are seeing only one slide, but having the multiple slides, we can cut short the whole screen into many divisions, like 1, 2, 3, 4. So four axes can go on. We can do the 4 axes at the same time. So this can be supported in database management system also. Next, we can shade the data to and multi-user transaction also possible. For example, I can send my amount to other side At the same time, I can receive the amount from other side. At the same time, I can invest in shares also. And sometimes I can do multi operations in accounting, Google Pay, Paytm, etc., etc. All these transactions can be done by this single data. Okay. So this is the database. How the database can be managed. DBMS allows entities and relations. Entities means the real facts and the relation among the facts among them to form a table. So a table is nothing but the combination of entities and relationship, that is records, tuples. A record or tuple is the same, of course. Attribute and the column, of course, is the same. Next, coming to the asset property. Asset property is nothing but A stands for atomicity, is only one. So it has no duplicacy at all. Consistency means perfection. It is consistent in nature. It is isolated from the other users, depending upon the privileges and the security what are privileges by giving grant, revoke. Some commands are there where we can give isolate to some people and giving privileges to other people. And durability, it is very constant till the system is a system is there and this is the system is working. Even if the system is dead, our data can be stored in cloud computing or some other fog computing or fog storage. We can store in somewhere. So it is always till the world ends. Even after the world ends also, our data can be stored. Next, DBMS supports multi-user environment. At the same time, not even one user, multi-user also can be accepted, can be supporting also, depending upon acceptance privileges. There is a special command for this. So it has that feature also, that characteristics also, that allows users to access and manipulate data in parallel at the same time. Parallel means at the same time. So these are some of the features. Characteristics and the features are the same. So no need to get confused. So that I'm telling you the more elaborate things. Apart from this, there are so many characteristics are there where we can see in the coming sections also what are the most complex characteristics, how we can use, how many tables we can relate. Can we relate with multiple tables? And how it is done practically. This all we can see in the labs also. Next topic is file system versus DBMS. So DBMS or flat file or file system is the same, of course. So DBMS is nothing but a multi-user, where a file system does not support multi-users. So file means it is nothing but uh, set of pages where we store our records, like our passbook, all important documents in our almaras or in our safe place, in some lockers, etc., etc. So these are called file system. This is not done with the soft copies are not done. For example, house house housing plan system, so where we can see this is all a hard copies. These are called files. Set of documents, some important documents like our certificate, some important like bank statements, bank accounts, our passbooks, etc. Whereas DBMS is nothing but it is a virtual concept, virtual systems where multi-users can access and do it. Next, this is a physical file system is a physical one. So that is also called a flat file management system. Coming to the second point, designed to fulfill the need for small and large business. So when we have small business as well as large business, or we can fulfill the need, the necessary to do that business with the help of DBMS very accurately, perfectly, without any duplicacy or any frauds also. Whereas file systems and manipulations, it is only limited to the smaller files only. So some manipulations can go on. Manually, some manipulations can go on. Whereas in DBMS, manipulations cannot. So the next point comes to that point only. Remove redundancy, duplicacy, and integrity, where it can all be integrated and avoid the duplicacy. Redundancy and integrity issues are available in file system. Next, DBMS software is expensive one, but in the long term, total cost of the ownership comes to the cheaper rates. One time investment it is. Next, one type investment means not lifelong. It depends upon the upgradation of the DBMS software. File system is nothing like a record system. It is cheaper. It's nothing but collection of papers or the printouts or something like this. So we can store it and store it. But once any ad hoc environmental changes comes, this all get erased. For example, some rain comes, water comes, our pages might get spoiled or get destroyed also, can be burnt also. But DBMS is nothing but a software which cannot be cannot be destroyed. It is stored in somewhere where security is being allowed there. Next, easy to implement complicated transactions. So any complicated transactions are there, it's very easy to implement. Whereas there's no support for the complicated transactions. So many differences are there, only few points are there. Few points I have just mentioned in the slide. So many is there. We can write pages after pages. Next. The next topic goes to the model and types of DBMS. There are models and types of DBMS. They basically four types. So many models are there, but we learning for according to theoretical purpose some four types. That is a hierarchical database, network database, relational database, object-oriented databases. Okay. So let's read one by one. Next, coming to the hierarchy. Hierarchy means what? There is some top, middle, and low level. So there are some levels in this. So there is a root node, middle node, and the child node, or it is called a baby node. Okay. So it is hierarchical database. The model database is organized in a tree form, tree-like structure. Data is stored in hierarchical, that is top to bottom or bottom to up format. Data is represented using the parent-child relationship. In hierarchical database management system, parent may have many children, but children have only one parent. This is universal universal phenomena. Okay, so coming to this, let's see the diagrams. Here, what happening is there is a root node where the hierarchy starts. So it is having many child, and this child is having a sub-child. So this can be called the third level, first level, second level, or third level, or zero level, first level, or second level. So totally there are three levels. We can have even sub childs also. Okay, it's like a tree structure. We can follow the top down model or bottom up model. Okay, the advantages of hierarchical model is very simple. It provides it data integrity since it's based on parent-child relationship. So whatever we have uh, kept kept all these features in the parent, this child can get inherited like this some and these features again can be supplied to the sub child also, and this sub child also can interrogate with the root from the parent also, so super parent also. So so this also leads to the concept called abstraction also. A little tendency of abstraction features has also come here. So next is provides data integrity since it's based on parent-child relationship. Data sharing is feasible since the data is stored in a single database. So your feasible is what? It is very easy to be accessed. Data sharing is easily can be accessed, easily can be shared, easily can be manipulated. It is something very user-friendly type since the data is stored in a single database. Even for larger volumes of data, this model works very perfectly. But apart from these advantages, there is also disadvantages. Implementation is very complex, and because we have to write lots of programs in this, and database administrator has to give us some notations or something like this. We use that notations, and administrator will take care from the higher level. This model has to deal with anomalies like insert, update, and delete. So we have to deal with some type of commands like insert, update, means what data can be inserted, what data can be updated. For example, we are in the first year. When we come to the fourth year, automatically it has to update. So what is the command for that? Who is going to deal with this? This is one of the model. Hierarchy models also support this. Next, delete command. Maintenance is difficult since changes done in the database may want you to changes done in the entire database structure. Suppose the root node, the root database, if you make any changes, it will be affecting the child database also, the sub database, which that changes is not, sometimes is needed, sometimes may not be needed, depends upon the utility. So that the maintenance is quite difficult. Next model, we are going to the network model. A network is nothing but it allows there is no connection. There is lots of connection between the child and the parent and the subchild. So its network is nothing but communication of a different areas. Areas you can go to. Suppose Hyderabad is one area, Chennai is another area, Bombay is another area. So this network model supports this. So data network database model allows each child to have multiple parents. So this is another concept. That means we can have one type of storage. Suppose all the main databases can be stored in a server. So when 10 people want to access it, we can have 10 duplicate tables. So we can access in that again, club all that and see what all the duplicacy, everything. So this is all done again stored in the server. So there, this is nothing but help of the network database model and to have multiple parents. It helps you to address the need to model more complex relationship like the orders, part many to many relationship, etc. For example, I want to have some order. Suppose I'm a family member here. I'm the mother of this family. I want to pass some type of instructions. So I will not pass one by one. I'll be telling all in one statement. So all will follow it automatically. In our case also, our boss is there. Our boss, what he does, he tells one word to the subordinate, and it all goes to the all the subordinates to the intermediate level. From the intermediate level, it goes to the all to the lower level. So what happening is it is one type. So it's like a broadcasting, we can tell in fact. So that type of orders can be done for many to many relationships. Relationship concept will be coming in the coming sections. In this model, entities are organized in a graph which is accessed through several paths. So we can tell the accessing can be done in any path. Suppose here the order line, the product, here the products are available in the storehouse. The order line can be taken from this order. This order line is from this order, and this order is from this customer. So the customer gives the order. The order is being arranged through the help of an order line file. And here the shipment and delivery can be done from the warehouse to the destination. So this is what is called entities are organized in a graph, which is accessed through several paths. Advantages. Easy to design the network model. This model can handle one-to-many, one-to-one, one-to-many, and many-to-many relationships. It isolates the program from other details based on standards and conventions. So it's very easy to implement and easy to design also. It follows the relationship called one-to-one relationship and one-to-many. One-to-one means other person is one person is there, this also one person is there. So it has, so the receiver and the destination, receiver is one, the destination is one. So one to one only goes. For example, one to many means one teacher can tell 10 students. So the class of 60 students. So this is called one to many. Many to many means, for example, our ticket reservation is there. Many transactions goes on. When the website is open, many people can log in and many people can log out according to our need and the network availability. This is called the many to many relationship. The next is it isolates the program for other details. Even though we are booking our ticket, though it is from the ticket transaction data warehouse. So we are not, suppose I want to book a ticket to from Hyderabad to Bangalore. So I am only concerned with the trains of Hyderabad to Bangalore, or only concerned with the flights of Hyderabad to Bangalore. I'm not concerned with other parts of the world. So this is what is called isolation. Of course, flights are there, many flights are there, but I'm only concerned with the flight of Hyderabad to Bangalore. So this is called next based on standards and conventions. Based on standards and conventions. Next, coming to the disadvantages. Hmm. Pointers bring complexity since the records are based on pointers and graphs. Pointer concepts which we have seen in the first year, pointer concepts. Next, we have seen in the computer organization, where the records we use the pointer concepts, and from the pointer concept we can go to the graph theory process also. Pointers is a concept where it suppose there'll be one indexing pointer which starts like serial wise ascending order or a descending order. So even though you don't know about this pointer concept, let me explain you very happily. Here, what happened is there's a record. There can be some 100 records. So how can I count that records? The record starts from 1. So records comes from 1. So I'll be searching for a record. For example, I want 20th record. That means it has to fetch the first record, second record, third record. That is in ascending order. So who's taking care of doing this? Um, uh, who's taking care of all this? The pointer concept takes care of this. So we are going in a serial manner. Suppose we are going from 1, after that we are going for 2, and lastly we are reaching the 20th record. That is one concept that is called top to bottom concept. Other pointers also there which can come from bottom to up. Suppose there are 100 records. So we have to come from 100, 99, 98 till the point we reach 20. So we have to see that type of complexity. So many complexities are there, many theories are there behind that, and many logics are there, many algorithms are present for this. But the pointer concept, that indexing concept, what is there, I want to tell you briefly so that we have to proceed to the next section. So this pointer concept is a complex point in network model because it is based on pointers and graphs. Otherwise, it's not a problem at all. Changes in the database isn't easy. Database, because network model it is, Once we give that authority, it has suppose many to many relationships are there. See, once we deliver, it cannot be taken back. So that is the biggest problem here. So that database isn't easy to make any alterations. So that is called changes are not easy, so easy. That makes it hard to achieve structural independency. So structural independency means uh, structurally it is not independent. It is becoming dependent, depend on the base. The next slide we are going to the relational model. Here, the subject of the database management system is actually we follow the relational model. So relational model we follow and some other models also we follow. But a database management system, the basic funda is relational model or relational calculus or domain relational calculus. So relational model is nothing but it is one of the easiest model and we are using a normalized technique model where it consists of rows. Rows is called horizontal line and columns is called vertical lines. The combination of rows and columns is called a table. And the particular point we want to see that is called a relational model stored in a fixed structure to manipulate this structured query language. Or it is also called a SQL. Advantages of relational model does not have any issues uh, that we have seen in the previous two models. What we have seen, some network model, etc. Okay, that type of disadvantages we will not face in relational model because we have the options called update, insert, and delete. Have nothing to do with the model, but that models has very difficulty in the previous models network model, hierarchy model has some issues in updating insertion and deletion, but relational model takes very easy in this. Changes in the database do not require you to affect the complete database. So once we do one changes in one table, it may affect the other table according to our commands. Others, it may not affect the other databases. So depends upon the command what we give. So database management system is nothing but full of commands. So that is called a queries. So in fact, that is nothing but a structured query language. Implementation of relational model is very easy. To meet a relational model is not a tiresome, it's not a hectic task. It's not a very tired full task. Next disadvantages is database inefficiencies hide and arise when the model has large volumes of data. Suppose we have done some mistake, that mistake will not be easily being focused unless otherwise large volumes of data has been running and there a point will be there where the input will not match with the output. So that time uh, we that at that time only we will find out that there is some mistake is going on. Till then we will not find out. That type of inefficiencies is not inefficiencies are present in database, but we still have some commands with upcoming commands as the upgradations going on. So we are able to face that also. Next, the overheads of using relational data model comes with the cost factor, which we have to use very costly hardware and devices. To maintain the relational databases, we should have a very costly infrastructure or hardware and the software devices. The next model is called the object-oriented model. This is also a part of the database only, but we also club this object-oriented database also to some extent. The object-oriented databases. So, for example, we have some menu here. Next view here, shape here, line, circle, triangle. So this is nothing but a object-oriented database. So we have some relational operators. What we are going to see there is arrow mark from menu to the view, and there is some also arrow mark from here. What type of aggregation it is. This all will be done in the object-oriented model, which will be following the next section. The object-oriented model data stored is in the form of objects. So objects means which is something getting entered into the entity. The structured, which is called classes, which display data within it. So it consists of classes. In these classes, we have objects, and this whole object and classes constitute of an entity. Okay, and this entity, a group of entities will be there that forms the full structure of it. It is defines a database as a collection of objects. We store both data, members, values, and operations. What are the advantages in this? It is a complex data set, can be saved, retrieved quickly and easily. Object databases are not widely adopted. Object IDs are assigned automatically here. Works well with object-oriented programming, but there are also some few disadvantages, like it's not widely adopted. In some situations, highly complexity can cause the performance problems. Object-oriented examples, what? For example, Java, C++, uh, is next. There's some other things also there, hash. So some of the softwares are there which uses software object-oriented programming. So, but that is a layman can't understand. But database management system, any layman can understand. That means unless otherwise we know the programming language, object-oriented programming, uh, we cannot operate on that. And JavaScript or so many things are there which a layman can do, because nowadays world is nothing but look and feel. Whatever we're looking, we have to feel and we have to implement that. For example, we can see a table, we can see the entities going on, what are the money coming, what are the money going, what are the entities coming inside the table, what are the entities going on. We can see visually, like as we see our TV or a film, how we're watching the film or watching a YouTube. Like that, we can see a relational database. But object-oriented database, we have to have objects in that. We have to write programming in that. Using that objects only, we have to tag it or the whole program. Next, coming to the next slide is what are advantages in that and disadvantages in object-oriented models. Complex data sets can be saved and retrieved quickly, very easily, because it's an object-oriented type. Object databases are not widely adopted. Only few members adopt who are highly technically sound in like software developers. Object IDs are assigned automatically. Works well with object-oriented programs. Next disadvantages is not widely adopted. Everybody cannot go for the Java programming or a programmers, developers like this. Some people go for the admin side. Some layman usually uses some concepts like rows, columns, like Excel. So they store everything in the form of Excel sheets. Excel is also an example for database. Next, in some issues, the high comp can cause because there is a performance problem also. Advantages of database. They offers a variety of techniques to store and retrieve data. Database management system serves as an efficient handler to balance the needs for multiple applications using the same data. Next, uniform administration procedure of data is needed, is available. Application programmers never expose the details to the data representations and storages. The database management system uses various powerful functions to store and retrieve data efficiently, offers data integrity and security. The database management system implies integrity constants to get a high level of protection against prohibited access to data. Database management system schedules concurrent access to the data in such a manner that only one user can access the same data at a time. Reduce application development time. It reduces the time, application development time, it reduces. So coming to the explanation of this, um, so database management has lots of techniques to store and retrieve data. They have followed so many techniques are there. Only one way technique is not there. So multiple techniques are there to store the data and to get the data. The second point is it's an efficient handler. It balances the multiple applications at the same time with the same data. Next, uniform administration procedures on data. It has administration procedures for data is uniform. So whatever administration procedures we are following, it is the same for each and every person. Application programs never expose, there is no need for the application programmers to expose the other data. For examples, I want only the particular person called Ram. I want only his phone number. I will not display the other details like his account number, how much salary he is getting, what is the balances he's having in his account. Only few. I want only cell number. Only that I can expose. That type of applications are being done in database management system, and is very powerful functions to store and retrieve data efficiently. It also has data integrity and security. So integrity also is present and security also, like grant and revoke and some other commands like that. Suppose we have even suppose we can delete the data, we can have rollback for the data, we can delete permanently also. So some other concepts also are there, which we see in the coming videos or coming sections. Database management system employs integrity constants uh, to get a high level protection against prohibition access to data. So it has a complex integrity constant and and simple integrity constant also to have protection of data. Next, it has concurrent access to data such that only one user can access the data at the same time, can access many data at the same time. See, one thing is I can do both the things. I can write it at the same time, I can listen at the same time, I can store it. These three actions can be done by the single command. Reduced application development time also. So this is one of the some of the few advantages. Of course, there are some disadvantages are there. These plenty may offer plenty of advantages, but they are also having few disadvantages, a few flaws. Cost of hardware is very costly. Cost of software is very costly. Next, it is having is quite high and increase the budget in organization as the data goes on. As the data expands, the hardware cost and the software cost rises to that some rises abruptly to some level. Most database management offer complex systems. So the training for the users is very much needed, and the training process is also a costly process. Next, in some organization, all data integrated into a single database, which can damage the systems. It cannot give all the integrations also. For example, electric failure is there, all the data is corrupted. There is no data storage media. So we should have a hard copy or type like that if we follow the individual organization. Otherwise, you can take a rent for a cloud where you can store it in a cloud, or we should have a good data warehouse or data mining concepts. Or that much data storage capacity should be there. So we maintain some hard disk or something like pen drive for for an individual organization. Next. use of same program at a time by many users sometimes leads to loss of data. So for example, this is the main disadvantage for money transaction. The bank, we are withdrawing the money, at the same time we are depositing to the other person. Meantime, current goes. What happens? Of course, there are some commands are there to protect that, but sometimes what happen is when you are doing some shares or something like this, multiple transactions going on, or multiple access, it may lead to some loss of data, but this is very rare case. A database management cannot perform sophisticated calculations also. But what happened is, coming to the previous point, use of same program at the same time by many users may lead to the same data. Yeah, transactions of money, once your money has been cut, we cannot, suppose power cut is there, and we have not, sometimes the money transaction is about to go on, we will not get the money refunded. Sometimes the transaction goes, we'll be losing such money. So that type of problems arises also we are seeing in a daily world, examples we are seeing in a daily life, right? So see, once we have clicked it, the money goes. So sudden the current comes, it also takes it. It is being granted. The transactions is being granted, but we have not clicked the button. Sometimes the money, the amount will be debited, and it will be credited to the other side. So this is all daily examples which are seeing in a daily life. The next topic goes to the levels of abstraction in database management system. There are three levels in data abstraction. That is the one is the physical level. The second one is the logical level, and third one is the view level. So coming to the physical level. So physical the levels means data abstraction. What are the features we can take, at what levels, how many levels we are maintaining. So the first comes the physical level. This is the lowest level of the data abstraction. It tells us how the data is actually stored in memory. The access method can be sequential method or random access or file organization methods like B trees, hashing tables used in the same. Usability, size of memory, and the number of times the records are factors which are needed to know while designing the database. Suppose we need to store the details of the employee, blocks that storage and amount of memory used for this purpose are kept hidden from the user. That means that the data is being hidden. That means it's been blocked. So that type of is there in that are the features of the physical. Okay. Close करेगा. तो तीन recording. Stop. Stop.